Hello, hi, how's it going? So we've got this program and if we run it, we can see our model. Looks pretty good. There's just a few things I'm going to change. We can get a little bit closer. See if this works. Okay, that looks good. So we've got a closer view. Now it still looks pretty good, and the issue is that the texture is fairly simple. It's hard to see details. So I found this other texture, Marble 2. Now let's run it with this texture instead, and something will become apparent. Create texture image, Marble 2. Okay, so again, it kind of looks okay, but can you see around the top of the head and so on? There's some weird things going on. This is what's called undersampling the texture. So basically, we have a pretty high resolution texture, and we're drawing it in a small space. Well, then we're going to have some pixelation because we're just taking a few samples from a high resolution texture. It's kind of crunching that data in together. So that's going to be the topic of today, is fixing that issue. I'm also noticing something funky is happening. Something funky seems to be happening with the normals. How did I miss this? That's much better. Okay. So it's funny, I'm always finding things. So the error that I made was in the vertex shader, I kind of had these around the wrong way. So again, location 0 is the normal, location 1 is the texture coordinate. How did I miss that? I don't know, but should be fixed now. So let's get to the topic of today's video. It's funny, I always start a video and then the first 5 minutes of the video is me fixing mistakes from the previous video, but that's, like, live and learn. Okay, so we are going to produce what's called a MipMap. I'm sure you're familiar with this, but the basic idea is a MipMap is you take your image and then you successively halve the width and height of the image to produce a series of smaller images. And then depending on how far or close an object is, we sample from different levels, so different texture resolutions. And one of the benefits of this is when objects are far away, we're not using a lot of texture memory to render them. And then another benefit is it helps to reduce that undersampling sort of issue that we were seeing before, like the blurriness, the pixelation around the smaller polygons. So we have, if I can find it, we have our texture image stuff. We're also going to track the number of MipMap levels. That's fine. Okay, so when we create that image, we need to calculate how many MipMap levels. What's going on with my voice? We need to calculate how many MipMap levels to generate. Now, let's say that we have an image which is 256 by 256. That's 2 to the power of 8. That means we can halve the width and length of that image 8 times. So what we want to do is the number of MipMap levels will be the base 2 logarithm of the image's size, basically. So we'll get that going. And I'm just going to add +1 just as a catch-all kind of error case. And this is okay, because if we try to generate more MIP levels than the image will support, well, in our MipMap generation code, it's still going to be checking that we're not trying to halve too much, if that makes sense. Okay, so the next step is we want to update this a bunch of these. We want to update this create image function so that it takes into account the number of MipMap levels. Well, actually, let's go here, create image view. That will need the MipMap levels as well. And that is used down here where we say level count. No mip mapping. Yes, mip mapping. Yeah, someone's going to shout at me, so I'll just get rid of that comment. All right, cool. Cool, awesome. So create image view works. Create image is going to need it as well. And that is down here in the mip levels argument. And then transition image layout is going to need it. Over here in level count. So nothing too crazy. We just have a bunch of errors that we need to fix. 684. All right, so for the swap chain, that is going to have one MipMap level, which is equivalent to not using mip mapping. And then 1323. You can see what I'm doing here. We're just popping through and fixing all of these. Okay, now this is our texture image. So we actually do have a number of MipMap levels. Okay, 1328. Transition image. Again, this is our texture image. 1403. Right, so this is texture image view, so this will take that argument. 1497. That's depth. Okay, so the depth image does not have any mip mapping. And same with its image view. Okay, so we're good. Cool. There is a little more to it than this. Of course there is. So we've created this image, but what are we doing? So we transition the layout so the image can take information from our staging buffer. Cool. So then we send the information to the staging buffer. Then at the moment, we're taking that image and we're setting it so it's optimal for the shader. However, what we want to do is we want to generate MipMaps. And OpenGL has a function to do this by hand. OpenGL has a function to do this automatically. We do not have that luxury. So we will create our own function to generate MipMaps. What this will do, well, I'll kind of explain it as I do it, but right now our image is set up as a transfer destination. First of all, we want to set it up as a transfer source and then set the level below to a transfer destination, and then we want to copy from this current level to the next level and then put that in a loop. So we're progressively copying images down to lower resolutions and storing them in because when we call this create image, that reserves memory for the image as well as all of its MipMap levels. Okay, so we're progressively copying down to lower resolutions, and then after we do a copy, we set the previous image which was copied so it is then shader optimal. So I realize that's a bit of a mouthful, but as I code this out, this should make sense. To start with, so we're not going to use this line. I'll just write in the function call that we're going to use. Okay, so this is a general function which will take these bits of information and use them to generate all of the MipMap levels for the image. Now let's create that function. Okay, cool. So the mechanism which is going to be used to copy an image down to like a downscaled lower resolution version is called linear blitting. Blitting literally meaning copying memory from one location to another, and linear meaning we apply a linear filter to downscale the image. Okay, so let's set this up. Now, these commands will be based on a command buffer. Everything in Vulkan is. What we're going to do is we're going to set up a command buffer and then repeatedly record commands to the buffer to do the whole operation and then submit that buffer. Okay. Okay, so we're still just kind of setting things up at this point. This is going to use a lot of image transitions, and hopefully they make sense as we type them out. I type them out, but all of these image transitions are going to use a barrier, so we're going to set up the common variables of the barrier up above. Okay, so the first thing we need to do is we've got this MipMap level and it is set up as a transfer destination. We need to set it up as a transfer source because we're going to be copying from it to a lower resolution. Now, as I write this, I just remember that we need to set something up above. When we create the image, it needs to be not just a transfer destination in the usage flags, but it needs to be a source as well. So yeah, it may seem a little confusing, but remember, what we are doing is we are indicating to the library what all the possible use cases for this image are going to be. So it's aware ahead of time. It's not going to set an image up to do both transfer source and destination at once. That's crazy. That will be handled by the transitions, which we're defining down below. Okay. Okay, cool. So we submit that. So that will transition the image into write mode, basically. Okay, cool. So we set things up with this structure so this structure describes a memory copy operation. Hopefully this is self-explanatory. So offsets 0 and 1 are like the position of the top left and bottom right corner, if that makes sense. Remember, with images, they're set to have a depth of 1, and that's like a depth of 1 pixel, or texel, if that makes sense. By the way, pixel stands for picture element, texel stands for texture element, so that's why I'm using texel. Okay, so here we're copying from level I-1 down to level I. So on the first operation of the loop, we've got the base level, which is level 0. We take that, halve the dimensions, and copy that down to down to level 1, and then the process repeats. Here we are using a ternary operator, so this is the test that we're doing. If our width is bigger than 1, if that's true, then the first statement is submitted. So we take the width, halve it, and submit that for the offset. If that's false, then we just keep it at 1. This is making sure that if for some reason we have got a width different to the height, well, then we can't halve everything equally, right? So let's say that we run out of width before we run out of height. Well, then the height will keep halving, but the width will always be 1 pixel. Sorry, 1 texel. Okay, cool. So that is set up for blitting, and we can go ahead and blit that over. Cool, so we copy that over. What have I done here? Oops, missed an argument. So, what are we saying? We're submitting this on our command buffer, which was generated up above. We're copying from image, which is in source layout, to the same image at a different MipMap level, which is in destination layout. Okay. And we're just passing in the structure up above, and we're telling it to do linear filtering. Okay, so let's say we do this, and we're at, I don't know, who cares? We're at step 3 of our loop. So we're taking level 2, so that's I-1, MipMap level 2, copying it to MipMap level 3, but then MipMap level 2, once it's being copied from, it needs to be set into shader mode, basically. So this will be pretty much the same as before. And we don't need to set the MipMap level because that was already set above. Okay, so we want to now transition it from source optimal to shader optimal. Yeah, okay, that should be fine. Cool, so then what we need to do is we need to shrink our MipMap size, because above, okay, so let's say we're at level 0, then we've got the original MIP width and MIP height, and we're copying to a half of that. But then when we step to the next step, we want to halve these variables so that when we go to level 1, we will have a half of this. I hope that makes sense. We're just going to halve everything. Okay, that's cool. So what we can do now is we want to end the buffer, and that would be good. However, just note that this loop that we're doing up here is what I would call like a look ahead loop. Right, so let's say we have a really big image like 2 to the power of 16, then we'll have 16 MipMap levels, and this loop will run up until one before, like up until level, so 16 MipMap levels will be level 0 up to level 15. This will go up to level 14, and it will work with level 14, copy to level 15, and then set level 14 to shader optimal. The point I'm trying to get to is that we need to, after we've called the loop, not that bit, not shrink it, after we've called the loop, we need to call this bit one more time to set the final MipMap level, because the final MipMap level will not be set within this loop. And here we do need to set the MipMap level exclusively. Okay, that should be fine, I think. So let's jump into this and see if it works. I guess I'll just set that to release. Doesn't make a difference. Okay, so it is working. That's encouraging. However, we are still getting the same texture issue. That's not so encouraging. Okay, so what is going on here? Well, if we look at... So we've got the MipMap. Hate that word. The more you say it, the less it means. So I've got the MipMap set up, but the control of that is set by... Where am I? I'm going crazy. It's set by the sampler, so wherever the sampler is. I'm going crazy. It was there. Okay, so it's all in this bit, the level of detail. So the funny thing about level of detail is it actually kind of works the opposite to what you would expect. 0 is at the eye level. That's kind of like maximum level of detail. But I guess what they mean is like the minimum number that level of detail can go to. And then maximum level of detail is saying, okay, how many MipMap levels can we go to? Does that make sense? So here's what we can do. We can... I'll just comment this out because we might use it later. But what we do is we set this up basically to correspond to our MipMaps. Okay, cool. Now have a look at that. That's looking nice. At the top of the head, the fuzziness has gone away. Those errors have gone away. That whole thing is, yeah, that's looking sweet. I guess the only issue we have is if you look at some of the edges of the polygons, they do sometimes have some jagged lines. And that's kind of what we'll be looking at in the next session. But right now, the detail's nice. Anyway, that'll be it for now. Have fun, and I'll see you later. Bye.